Hello everyone, hope you're doing good. Welcome back to my channel. Today we are at day 28 of the October Daily Code Challenge 2024, and we have a very good question in front of us. It's a medium level question, but you will realize that it's slightly on the easier side because the kind of complexities they have given here, the kind of hints they have given here, it definitely makes it easy. From the last few days, if you see, we are getting a very good number of questions which are marked as medium or hard level, but after going through the details of it, like, at least after understanding the hints or understanding what the examples are, I am damn sure that you will be able to do it if you have been following this challenge from some long time now. Okay, let us say 1 month, 2 months. If you have been consistently doing it, I am damn sure that you will be finding this particular week very easy. Okay, there were weeks where the things were much harder. Okay, so coming to today's question, 2501, longest square streak in an array. Okay, so before going to the question, just see what are the inputs given to us. We are given a nums array. Okay, integer array, and we have to return integer as the output. Okay, so you are given an integer array nums. Here we are talking about a subsequence. So before I go to the question, can you quickly tell me what is the difference between a subsequence and a sub array? This sub array means it has to be uh, continuous elements. For example, this is the array given to me. Then if I take any continuous set of elements out of it, okay, it will form this array. For example, this any continuous element, continuous set of elements I have to take. For example, this, okay, this will be a sub array. But when it comes to subsequence, what is more important here is it need not be continuous, but the order should be the same. What it means is, for example, I can take 3, I can take 16, and I can take 2. Okay, that will form a subsequence. Remember, they are not connected directly. Okay, but their ordering should be retained. For example, 3 should come first, then only 16 should come, and then only 2 should come. That is what the subsequence means. Subsequence is more to go with the sequence of the elements. Okay, it has nothing to do with the if the elements are connected or they're nearby adjacent to each other or not. That is not something which we care for when we are talking about subsequence. Okay, but that matters when we are talking about subarray. In this particular question, we are dealing with subsequence. Okay, a subsequence of nums is called a square streak. Okay, we are going to see the definition of what a square streak is, but just remember, we are calling a subsequence as square streak if two conditions are getting satisfied. What are they? The length of the subsequence is at least 2. Okay, then after sorting the subsequence, that is, I am taking subsequence, okay, out of the array, and then I am sorting the elements of that. Okay, after sorting the subsequence, each element except the first element is the square of the previous element. Okay, that is it. So what we have only two things: it has to be at least 2 length. Okay, and except the first element, all other elements should be a square of the previous number. Okay, return the length of the longest square streak in nums. Okay, or return -1 if there are no square streaks. So we have to return -1 and not 0. Remember that. This again forms a some. See, you will be knowing how to solve this question, but when you have a short span of time, for example, say 10-15 minutes in online interview, sometimes you miss this kind of constraints. Okay, so remember, in this case, we'll have to return -1, not 0. Okay, as simple as that. A subsequence is an array that can be derived from another array by, okay, this thing I have already explained to you how it is. I've given you examples also, so I'm not going through this again. Okay, you can go through it for your own benefit. Now coming to examples, it's a very simple example. If you see, this particular is given to us, but if you see here, I have 2. Okay, the square of 2 is 4, the square of 4 is 16. So this particular subsequence, if I take 4, 16, and 2, and then if I sort them, I will get 2, 4, and 16. Okay, this is the subsequence. Okay, remember how the ordering is: first 4 is coming, then 16 is coming, then 2 is coming. Okay, that is the subsequence. Now I will sort it, so it becomes 2, 4, and 16. And if you try to apply this particular rule now, okay, if you see, if you try to apply this rule, you will get to know that it matches. Okay, so square of 2 is 4, 4 square is 16, and the length of a subsequence is obviously greater than or equal to 2 in this case. Okay, so the answer in this case will be 3. Now see the other example. Okay, here if you try to see, we will not get any subsequence, okay, whose length will be greater than 2, that is greater than or equal to 2, which satisfies this particular property. Okay, for that reason, here will be written -1 and then not 0. Okay, as simple as that. If you see here, it is of 10 power 5. The value can also be 10 power 5, and the number of elements in the given array also can be 10 power 5. Okay, so that is it. Now coming to the solution. First solution I will show you using a dictionary approach. In Python we call it as a dictionary. So what you are seeing here highlighted on my screen is actually a dictionary in Python. Okay, in other languages we also call it as a mapping, okay, or a key value pair. As simple as that. So using that, I will just show you how it works. Okay, the time complexity in this particular case, because just remember that here the time complexity is more related to with if you're involving sorting or not. If you're involving sorting, then it will be of n log n type. Okay, here also I've involved sorting. Just for your benefit, at the starting itself I'm saying that. Okay, So this will be my time complexity of the solution, and you will have to tell me what will be the space complexity of it. Okay. So what I'm doing, I am taking an answer, initializing it with 0. Okay. I know I don't have to return 0. It will be -1 in case if I have, you know, uh, this particular thing. Okay. Stochastic of length 0. Even then I have to return -1. Okay. Next, what I'm doing, I'm sorting the elements. Okay. I'm sorting the elements. Then, okay, yeah, I hope you can see it clearly now. Okay. Okay. First time, okay, this is a thing I think I explained to. I am sorting it out. Now remember why sorting is important. So see here, it can be done without sorting also, but remember, though sorting increases the time complexity of it, I know that without sorting you can do it in n, O of n complexity, time complexity, but I do not think that is going to be a best solution here, because that will involve a lot of unnecessary computations which we can avoid. Okay, which we can avoid. I will show you that how. Okay. So what I'm doing, I'm simply sorting it, because see the nature of the question here. See, if you are starting with 4 first, okay, you'll get the 4 square is 16 which is present, but still it will not give you the answer, because to get the answer you have to start with 2. Okay, or you have to move in either direction. That is, if you are starting from 4, you have to go below that also, or you have to go and above that also. Okay, that is, you have to go for 4 square and like that, then on, and you have to also go for 4 root. That is the square root of 4, and then on. Okay, like that also you have to go. In that case, it will be a good solution. But remember, if you're going only around one direction, that is, if you're starting from element and searching for a square of that, then searching for a square of that, the square of that, okay, then you'll have to do sorting. Okay, that is the only thing I want to say. Though it makes the time complexity n log n, without that you can get O of n, but still it will save you a lot of computation. You will get to know when you go to the depth of this question. Okay, after this video, just go and try it, and to do it with O of n complexity, you will get to know that we are doing a lot of unnecessary computations here. Okay, so I'm declaring a map. Initially this doesn't have any key value pairs, and it's going to be the length of the nums. Okay, what I'm doing, I'm going to each element. Remember, it is already sorted. Okay, so I will be the smallest element initially. It will be 2 in this case. Okay, if you take the first example, I will be 2 at the starting. What I'm doing, I'm taking the square root of that. See, there are many ways to do square root in Python. You can also import certain libraries and do the square root. Okay, in my case, I'm simply using the inbuilt things. Okay, for example, in Python, this is the square operator. Okay, that is I raised to the power 0.5. Okay, if you are good in maths, you will get to know that it is basically the square root of it. I'm taking a square root of it. Okay, that's why I'm calling it as a root. Okay, what I'm doing next, I'm trying to search for root in map. Okay, that is whether the root is present or not. If it is present, what I have to do, take the, okay, see, this thing you will get to know only when I show you the examples. That is the dry run of it. Don't worry, just for now, bear with me, you will get to know it. Okay, what I'm doing, if root already exists, then take the value of it, add one to it, and store it as map of I. That is map of the current element. Okay, if that value doesn't exist, what you have to do, multiply I with 1.0. Why I'm doing this, again I will show you that, and start it with 1, as simple as that. Okay, this thing will be clear when you see the example. This I am printing just for your convenience. Okay, next, I'm going through all of the values. Okay, remember, there are, a map is a dictionary, right? So there will be keys, there will be a set of values. In this case, I'm going only through the values. Okay, among all the values, whichever is the maximum, I'm taking that as the answer. Next, what I'm checking, whether answer is equal to 1. If it is 1, return -1. Okay, this thing I already explained a lot in the starting. Otherwise, return the answer. Let me quickly run this for the test cases and show you one of the dry run of that. Okay, so if I can show you this. Yeah, so if you see here, this is going to be the mapping that I have. Okay, at the end of the yeah, after the end of the processing. Okay, so what happens here, see why I have multiplied. Okay, let me go for the full screen. Okay, so if you see here, I am multiplying here with 1.0. Why is that? Because see, whenever you take the root, that is whenever you do like this, let us say 4, if you take the square root, you are going to get 2.0. Similarly, so if you have to search 2.0 while storing it, also have to multiply it with 1.0. That is the reason why I am multiplying with 1.0. Okay, there is no other reason for it. Okay, as simple as that. So if you see here 2.0, I have the value of 1. So the idea here is, when I am at 4, okay, when I am at 4, what I have to do, search for a square root of it. What is the square root of 4? It is 2. Okay, so if 2 exists, take its value, that is 1, and add 1 to it. Okay, so I have to add 1 to this particular thing and store it as here, the value of 4. Okay, yeah. Now when I'm coming to 16, what I have to do, search for the square root of 16. Okay, what is the square root of 16? It is 4. Okay, 4.0. So take the value of that, okay, as it is, and add 1 to it. It will become 3, and save it. At last, what I have to do, among all the values, okay, these things are values, okay, these things are values. Among all the values, take the maximum and return this as the answer, and this is the answer. Okay, that is the answer. As simple as that. That's what I'm doing it here. Okay. So yeah, and that's what we are doing it here. And if you see here, this also you can basically multiply with I. Okay, and I let me do it. That's in front of you. Okay, this will be making things very clear to you because in both places it should be in the same way. Okay, yeah. Okay, let me run it now and show it. Yeah, if you can see here now, all the keys are having point 0 as their end. Okay, point 0 as their end. As simple as that. Yeah, now it is consistent. Okay, so that's what we're doing. Yes, so yeah, that is the basic idea. So what we are doing is, see, by the time I'm at 16, okay, remember first always sorting, that is 16 will always come at the end. So by the time I'm at 16, I would have also crossed 4 and 2. Okay, so when I'm at 4, I would have already crossed 2. So what I'm doing, take the value of 2 and add 1 to it. That's why the value of key 4 will be 2. Similarly, when I'm at 16, I would have already crossed 4. So what you have to do, take the value of 4 and add 1 to this. Value of 4 is 2, add 1 to which becomes 3. So 3 is the answer because it's the highest value, okay, among all the keys. If you see, that's what I'm doing it here. And remember, since because of the step, all the values by default will be at least one, okay? By minimum will be one only. So whenever the answer is one, that is whenever the maximum is one, that means the minimum will also be one. And that's why you have to return minus one in that case, okay? And that's why I'm writing the answer. This is my first, solution. I will also use the other solution using a set approach. Here, I'm using, a key value path, that is a mapping in Python, okay? If you find the time complexity of it, you will get to know that. See here, this will take O of n log n, okay? Other than that, you see here, I'm just going through each of the number set is okay. This particular follow will be O of n. Okay, this whole follow will be O of n. Okay, the mappings, that is this particular thing. What I'm doing it here, initializing it or finding its value. This all will be in O of one time. Okay, this will not consume more than that. So this particular whole thing on the whole will be O of n only. Okay, this again, I am going through all the values and I'm finding the max. This will be again O of n only, and this only will be taking slightly more than that. Okay, so the time to of it will be O n log n. Okay, and if you talk about space complexity, see, when it comes to space complexity, we'll have to see the worst case here. What is the worst case? See, worst case will be, yeah, see, by default also, if you see, we are creating a key value pair for each of the elements. Okay, for each of the elements, that means again, in our map also we are going to have n key value pairs by the end. Okay, here we are not removing anything, so we don't have to go for any worst case or best case complexity. And for any case, by the way, it will be always n key value pairs. Okay, so obviously the space complexity will also be O of n only. Okay, in this case the time complexity O of n log n, and the space complexity O of n. I've already segmented the solution and it works. I will give you this in the comments. You can go through it. Now coming to the other solution. See, this particular solution is using a key value pair. Okay. Now I will show you how it works using a set. Okay. How to use a set and get the answer. This will be a slightly trivial solution. Here you have to be very, very careful in some of the things. But again, see, when you solve more, you will get to know more. Okay. Because see, in a online assessment, if you've already started, let us say, using this particular approach, okay, you have already spent some time here. It doesn't make sense to go back to the any other approach now. The best thing will be to continue in the same approach. To do that, really remember that it definitely matters how much time you spent in your practice. Okay, using these kind of things. If you have done so, I am damn sure that even in the online assessment, even if you have spent some good amount of time here, you will be confident that yeah, I can complete it. Okay, that's what it is. So coming to this particular approach, what I'm doing here is that same thing, I'm sorting it out. Here I'm using a set. Okay, what is that? Set is going to be, you know, it's going to have all the unique values in the nums list given to us. Okay, in the given input, the given input array, whatever unique values are there, I'm going to show it as a set. Okay, so see, the idea of having set is that healthy searching becomes very easy. If I have to search a particular value, I can get it in over one time. Okay, otherwise I have to go through each element of the array in the order in which they are present and get it. Okay, that will take O of n time. So that is the best part of here. But remember, if you take this, it increases the space complexity, that it will be a 4 of n now in the worst case. Okay, when all the numbers are unique. I am defining a function here. What is this function doing? I will come to this, but let us see it below that. So this is from where the code starts. What I'm doing it here for I in nums. Okay, that is go through each element of the nums. Okay, if I'm checking it here, if this I is in set. Okay, if this I is in set, then call the function for I. Okay, now you'll be asking me if I is in nums, and obviously set is also found from nums. Okay, set is also found from the nums array only. Then why I am checking this? You will get to know this when you see the content of this particular function. Okay, so what I'm doing it here. So basically, remember in Python, one thing I want to tell you. See, this is a function. Okay, inside this function I'm creating another function. Okay, now I am using this non-local answer and set. Set you can anyway, like even if you don't declare it as a not non-null, it doesn't matter. But for answer, you should always declare it as a non-local. Okay, certain compilers will not throw error, but if you don't declare it as a non-local, then by default they will not take the value of this. Okay, they will not take the value of this. When you are using answer inside this particular function, by default it will be answer and some junk value, and you will be using it. You will not get any errors in some compilers. That's why it's always better to use non-local whenever you are using something that is not defined inside this class. Okay, that is coming from outside this class, that is outside this particular class. Okay, this particular class, you have to declare it as a non-local and then you have to use it. Okay, so what I'm doing it here, c is basically the current streak. Okay, c is basically the current string. P is the power of the current element. Okay, it is k double star 2. Double star 2 means k raised to power 2. Okay, what I'm doing, I'm checking if p is in set. Okay, p is in set. What I'm doing, increase it to 2 directly. Why 2? Remember, k is already there and k raised to power 2, which is p is also there. So that's why I'm directly changing c, which is 0, to c equal to 2. Okay, as simple as that. Then what I'm doing here, these two things are important. Remember, if you don't do them, there will be a lot of unnecessary calculations coming. Okay, that's why it's always better to remove them. What I'm doing, I'm simply removing p and I'm simply removing k. Okay, as simple as that. If you ask me why I'm removing the C, removing K doesn't make much sense. I agree, but removing P will make a lot of sense because this will not be triggering here again. That's why whenever the P value comes, it will not be triggered again because P will be removed from set. That's why it makes sense. Okay, as simple as that. Okay, then what I'm doing, since K is already used, I am allotting the value of P to K. Okay, I'm valuing the value of P, which is the power of K. I'm storing that value in K. That is whatever is K square value. Now it will be stored in K. As simple as that. Okay, if that is not that, if P is not in this set, what I have to do, simply remove K from the set because K is now checked, so that you can remove it and then return from this function. As simple as that. Okay, now let us say this part will not be executed if P is in set. Okay, P is in set. So what I have done till now, I have taken K. I have also found that K square, which is P, is also present. If I've done so, what I'm doing here, I'm uh, changing my current state to 2 and I'm removing both these elements from the set. Okay, and also I've allotted the k square value to k. Okay, that is here. Now this particular part of the code will start. What is this part? Till the length of set is greater than 0. Okay, that is, just remember here, why this is necessary is because, see, we don't want to keep searching for something. Okay, even if there is no element in the set, doesn't make sense to search, right? So for the reason, just as a precautionary condition, I'm using this till the length of set is greater than 0, because remember, we are removing elements, right? So that's why I'm including this particular condition. Okay, what I'm doing here, remember, currently k is k raised to power 2. Okay, whatever is k. Okay, currently after this particular thing, k will be k raised to power 2. Okay, what I'm checking now, again I'm doing k raised to power 2. Okay, first k is k, then it become k square, then now k is going to become k power 4. Okay, so what I'm doing, again same thing, I'm squaring k and storing it as a p. Okay, just like previously. Then I'm checking if k is in set. Okay, if it is in set, what I have to do, again increment c, that is the current streak by 1. Remember, initially we change it to 2 from 0, but after that, this is only for the initial step. After that, for every other such a condition, it will be only increased by 1. Then again same thing, remove p and allot the value of p to k, and then keep proceeding. Okay, if p is not present set, what I have to do, simply break out of it here. Okay, simply break out, as simple as that. If p is not present, there is no meaning in searching. Remember, here if you see, I'm doing some removal, right? But why I'm not doing any removal here, try to understand this fact. P itself is not present in set. Okay, if p is not present in set, only then we'll be coming here, right? If p is not present, it doesn't make sense to remove it, right? That's why I'm not removing it here in this particular case. Okay, as simple as that. So what I'm doing, I'm not doing it, and I'm breaking out of this loop. Okay, this whole loop I'm going to break out of it here. Okay, once I come out of it, what will happen? Okay, either I would have already returned from here. If not, only this particular thing will happen. And once I come out of here, what I'm going to do? Answer is equal to max of the previous answer or the current streak. Okay, or the current streak. Then come out of this function. Okay, this function will end here. Okay, this function will end here. Next, what I'm doing? Then again, for the remaining elements, if they are present in set, again call the function for them. As simple as that. So what is the advantage here? Okay, let me quickly show you what happens. See, initially, I'm going to sort nums. Okay, so it will start with 2. Okay, it will start with 2, then it will go to 4, then it will go to 16. Remember, all of them will be removed now. Okay, after removing, then what is the next? Okay, I will come out of this loop. Then what will be remaining? Okay, let me make it here and show you. Okay, that will make it very clear for you. Okay, because that is not sorted. Yeah. So what will come first? 2 will come first. Okay. Then 3 will come first. Then 4 will come first. Okay. Then 6, then 8, and then 16. Okay. That is what it right. So initially, what will happen? 2, 4, and 16 will be gone. Okay. In the first step, 2 will be gone. Okay. Then yeah, this particular 4 will be gone, and this particular 16 will be gone. Okay, yeah, now this is what our nums will look like. Okay, that our set will look like. So whenever the other nums are coming, they will not be passing through this condition. Okay, so the next time a function is called, it will be for 3. Okay, it will call for 3, 9 will be checked because 9 is not there, 3 will be removed. Okay, now 3 is removed. I will be coming to 5 again. 5 square of 5 is 25 will be checked. It is not there, so 5 itself will be removed here. Okay, now 8 will be checked again. 8 square is not present, so it will be removed. As simple as that. Now this particular loop will be ending. So by now the answer would have been already saved, and I will be reading that as the answer. So answer will be 3. So if you want to see the run of it, I can just run this and show you. This also I have segmented and it works. And in terms of the the run time, this solution works better than the previous solution, by the way. Yeah, if you see, the test cases are being cleared by this also. Yeah, this was the solution using the set. The previous one was using the map. So yeah, this here some of the things are important, because if you don't do the removal, you are going because the function will again and again call for that. Okay. For example, if I am already done with 4 and 16, see, if you start from 4, it doesn't make sense, because see, only if you start from 2, you will get the answer. Okay, that is the answer will be 3, right? That is this particular answer you will get only for starting with 2. If you are starting with 4, you will be going to till 16, you will be stopping it there. Okay, that is not going to give you the answer. That will only give the current stick will be 2 in that case. That's why it doesn't make sense to start with 4. That is, start with the lowest. Okay, and then keep removing the elements. Then keep removing the elements so that the function doesn't get triggered again, and you will save some compute. Okay, that is the basic idea. So again, this solution, if you see here, I'm doing a search, that is, I'm doing a sort. So again, it will be open log n only. And yeah, and I'm obviously using a set. So obviously, when the space count will be open in the worst case. If there are, the given input doesn't have any, you know, repeating thing, that is all the numbers are unique, then obviously that is the worst case, and the of and space only will be used in that case. Okay. So yeah, and that was all for today. This was a good question actually, and you can definitely go through the hints here. Okay. So one task that I can give you is that, see here they are talking about the length of the longest square stick possible is 5. Okay, you will have to explain me how is this coming. Okay, yeah, you can go through their editorial or you can go through the other solutions also, but you will have to tell me why is this important. And remember one more thing, see here again they're referring to constraints. That's why this constraint become very important. Okay, here I'm actually not checking if the after powering the element, that is the value of p, if it is exceeding 10 power 5 or not. If it is exceeding 10 power 5, basically you should not be going forward. But in my case, what I'm doing is that even if the power is not existing, okay, I'm breaking out of the loop. Okay, here I'm breaking out of the loop. Similarly, here I'm breaking out of the loop. So I'm not, directly using this condition, but you can also use that. Whenever the power exceeds 10 power 5, you should not be proceeding further. You can also include that part in your code. Okay, that is another suggestion from my side. So that will give you the impression that you are also paying, attention to these constraints. That is again important. Okay, so just research on this and let me know what are your thoughts on this. Okay. Yeah, and that was all for today. I have also discussed some of the important parts here, which could be coming as a follow-up question. Okay, if this particular thing comes in interview. Okay, that is all for today. If you like my efforts, if you like my video, please do consider subscribing to my channel. It really gives a lot of motivation to continue further. See you tomorrow. Thanks a lot.